The meteor that shot through the sky over central Russia on Friday, exploding into a shower of fireballs, created shock waves that were felt for miles. More than 1,200 people were injured. Shattered glass was everywhere, and thousands of buildings were damaged. Though meteors do fall frequently, such devastating events are rare. But remember, many scientists believe it was an asteroid smashing into the Earth some 65 million years ago that caused wildfires that changed the environment so much dinosaurs could no longer survive. And for generations, humans have been trying to understand the hows and whys of these missiles from outer space.
This is probably the largest exhibit in the world in terms of meteorites on display.
The Smithsonian Museum of Natural History has amassed a major collection of them, overseen by Linda Welzenbach. This looks like a piece of sculpture.
Iron meteorites are really interesting in many ways because they are fragments of an asteroid that has been completely disrupted. So we're getting pieces of something that at one time was a full planet.
In fact, most of the meteorites that land on Earth come from the asteroid belt, an area between Mars and Jupiter where space debris collects. And here's a little space terminology. Asteroids are minor planet-like objects that usually orbit the Sun. Meteoroids are much smaller bodies. When either enters the Earth's atmosphere, it's known as a meteor, and after it hits the Earth, it's called a meteorite. You've got 50,000 meteorites in your collection?
Yes.
Why are you still trying to get more?
Because every single one is a puzzle piece that adds to the information that we understand about the history of our solar system and the history of the development of the Earth.
Well, you put me in my place. Meteorites are so sought after that there's a little-known federal government project. The Antarctic Search for Meteorites program that sends scientists, including Welzenbach, on annual expeditions.
When somebody sees one, they stop, and their first job is to do a little dance. We have a wave that people do. Then we all converge on the site.
Ralph Harvey, Associate Professor of Planetary Science at Cleveland's Case Western Reserve University, has been leading the 37-year-old program since 1991.
The reason we know this is a meteorite is that burnt black coating.
Yes.
That's called.
He says it's not that there are more meteorites in Antarctica than the rest of the world, but that they are better preserved in the frigid landscape.
There are meteorites we've collected in Antarctica where they're so young we can't measure that age. There are others we've found that fell several million years ago, and there's everything in between. The average seems to be about 25 to 30,000 years.
22594.
To the scientists' delight, they've even found samples from the Moon and Mars.
This is an Easter egg hunt unlike any Easter egg hunt anywhere.
The yearly catch is shipped to NASA's Johnson Space Center. Here in the nondescript building number 31,
this is the air shower,
where you have to suit up to protect the meteorites from contamination. The precious cargo is unpacked and cataloged under the watchful eye of curator Kevin Reiter.
They're frozen from the time they're collected and returned all the way along the legs of the journey to get to Houston.
Each sample is carefully examined and given a name based on where it was found. So we get to see a Martian meteorite?
This sample is Elephant Moraine 79001. It's a basaltic rock from Mars.
In fact, it was studying a Martian meteorite found in Antarctica that led scientists to the discovery that there was once water on Mars. And though these ugly ducklings may all look similar to the naked eye, each meteorite has different chemical and mineral contents. Under a polarizing microscope, they are as beautiful as stained glass windows. But it's what they may someday tell us that really matters.
I would say that the study of meteorites is akin to where biology was in the pre-Darwin era. We're bringing back all sorts of funky new creatures, and we're trying to fit them into a framework and understand how one relates to another.
Since the Antarctic Program began in 1976, it's cost about $25 million. The Curiosity rover mission, now analyzing samples on the surface of Mars, cost about $2.5 billion and won't even bring back any material to Earth.
This is a way to get a piece of Mars that costs us 1/millionth of what that project might cost.
You've described this whole operation as kind of a poor man's space mission.
Poor person's space
Poor
mission.
person's.
The Antarctic missions have brought back more than 20,000 meteorites, and the program has loaned thousands of samples to researchers all over the world who are trying to make discoveries about the evolution of planets and stars. Still, at the Smithsonian,
we have calcium aluminum rich inclusions, and those were the first things to form in the solar system.
Antarctic meteorite curator Carrie Corrigan and her colleague Linda Welsenbach are well aware that some members of Congress want to shut down the project.
That's very disheartening to me because I think that's not looking at the big picture. I think that's a little short-sighted. This silly little rock, right, that it looks like you could just pick up in your backyard can tell us 4 billion years of history of the solar system.
As you might expect, there's major interest at the Smithsonian in what happened in Russia. And keep in mind, Friday's Russian meteor is estimated at about 50 feet in diameter, versus more than 6 miles across for the one believed to have wiped out the dinosaurs. So could something even worse ever be headed our way?
There are a lot of large objects out there, and at any one time they can be put into the inner solar system and intersect Earth's orbit. So the answer is it could happen.
But the unsettling reality is there's nothing researchers could do about it. So they are far more focused on the idea of solving the puzzle of how the solar system formed.
It's a daunting task for sure.
It is, but the picture does become slightly clearer each and every time we find something new. And the new questions that are generated from that next thing is what keeps us going.